Hello erudites, I'm Ben Saivan A. Alea, and for today's video, I will be discussing definition and equation of a parabola, a lesson 3 on a pre-calculus. Before we start, let's head to our learning goal. Students will be able to define a parabola. Students will be able to determine the equation of a parabola. First, the definition of a parabola. What is a parabola? A parabola is the locus of points x and y in a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. In other words, if you pick any point on the parabola and measure its distance to the focus, then measure its distance to the directrix, those two distances will always be equal. That balance is what creates the U-shaped curve we call a parabola. After knowing the definition of a parabola, let's head to the parts of a parabola. First, we have vertex. Vertex is the midpoint between focus and directrix. In equation, vertex is defined by h and k. Focus. Focus is a fixed point, equidistant to the curve and collinear to the vertex. This just means that the focus also lies on the same line as the vertex, and that line we will topic later. Directrix. Directrix is a fixed line, equidistant to the curve. Also take note, directrix is perpendicular to the vertex. This just means that the directrix is really important because it will help us to determine the orientation of a parabola. If our directrix is horizontal, our parabola will be opened up or down. If our directrix will be vertical, our parabola will open left or right. Focal length. Focal length is the distance between vertex to focus and focus to the directrix. It also denoted as P. Keep in mind that vertex to focus and vertex to directrix is always the same value, which means that if we have no directrix and we have vertex and focus, we just count those units to vertex to focus, and that value will also be the distance to vertex and the directrix. Axis of symmetry. Axis of symmetry is a line perpendicular to the directrix and include the vertex and focus. Also keep in mind that axis of symmetry also divides the parabola into two equal halves. Lastly, we have latus rectum. Latus rectum is a line segment that is bounded by the parabola, parallel to the directrix and passes through focus. Latus rectum is important because it will help us to determine whether how wide or thin our parabola will be. Now let's head to the formulas. Standard equation of parabola. This equation we see right now is only parallel to x-axis, which means our parabola is up or down. And this also just means that our directrix will be on a horizontal axis. Remember, our vertex is the value of h and k, and the p is the focal distance. Standard equation of a parabola parallel to y-axis or right or left. We are going to use this formula only if our parabola orientation will be right or left. This is the orientation of parabolas and their standard equations. As you can see, the down and left has negative 4p. Remember, down and left, we're going to use negative 4p. If we have up and right, we're going to use positive 4p. After knowing our formula, let's head to our problem examples. Okay, we have given vertex at origin and focus at 0, 4. So at first, let's try to write the given. We have vertex, and our vertex it's at 0, 0. And we have focus at 0, comma 4. At first, let's try to plot the given. The vertex at 0, comma 0 and our focus at 0, comma 4. Now we already graph our given points. Now we can tell the orientation of the parabola opens upward. So now we can try to get our standard equation. The formula of the standard equation of a parabola that opens upward and is at origin will be x squared equals 4py. Let's try to get our p, or the focal length. How do we get our focal length? So, like I said, the focal length is distance from vertex to focus. Now, we just count from vertex 1, 2, 3, 4. So, our focal length must be 4 units. Now, let's rewrite. So, it will be x squared 4 and rp, which is 4 units or 4, and y. 4 times 4 is 16, and y, and our x squared. Now this must be our standard form. Now let's try to find other parts of a parabola. We have directrix and we have latus rectum. We can just write it as LR. Now, how do we get directrix? Like I said, focus to vertex and focus to directrix is the same value. So if we count vertex to focus 4 times, we also count focus to directrix 4 times. So how do we do it? We count 1 downwards, 2, 3, and 4. Our directrix will be in here. So our directrix lies on y-axis. So our directrix is y equals -4 because we count from focus downwards, so we get -4. Now lastly, how do we get the latus rectum? Latus rectum can already found in our standard equation, 16. How can we sure our latus rectum is 16? Because latus rectum formula is absolute value of 4p. Now let's substitute 4 times focal length, which is 4 units, so we get 16. Now, we divide the 16 by 2. Why? Because the focus is its midpoint, so the length must be shared equally to both sides. So 16 divided by 2 equals to 8. Now let's try to get our latus rectum. So what we're going to do is we're going to count from focus 8 times to the left and right. So 1, 2, 3, 4, 5, 6, 7, and 8. So our latus rectum will be here. And other side, 1, 2, 3, 4, 5, 6, 7, and 8. So our latus rectum will be in here. Now let's try to graph it in Desmos. Now we found the points of latus rectum. Like, let's say, what if I can graph? What if there's no graphing? I need to calculate it manually. So let's head to our focus. So our focus is 0, comma 4. So if we have a parabola that opens upward, our latus rectum will move from x-axis. So our x-axis will be moving. So 8 and 4. That's our LR1. And our LR2 will be, we're going to minus because we're going to the left side, we're going to have negative 8, comma 4. Now there we have it. Now after getting all parts of a parabola, let's head to Desmos and check if our standard form is really correct. So, vertex at origin and focus at 0, 4. After getting its standard form, I put it in Desmos and it matched correctly with the given vertex and those two latus rectum. So, the equation is verified. Now, for our second example, we have focus at negative 3, 1 and directrix at y equals negative 3. So, how are we going to find the vertex? We have no given vertex, so that means we have no h and k. We can't get our standard equation yet. So, if you remember, if you count from vertex to focus and vertex to directrix, they are always the same countings. That's how we get our focal distance. So that means the vertex is the midpoint of focus and directrix. Now, how do we get the midpoint? How do we get the vertex? To get the midpoint, we are going to use the midpoint formula, which is x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. Now, our focus will be our x sub 1 and y sub 1. In directrix, how are we going to tell what point it lies on? Now, in this, I will use negative 3, comma, negative 3. I use the point negative 3, comma, negative 3 on the directrix because it's directly below the focus, keeping the axis of symmetry vertical. That means also the parabola orientation will be up or down. Now, in directrix, this is going to be our x sub 2 and this is going to be our x sub y sub 2. Let's substitute. Our x sub 1 will be negative 3 minus negative 3. We have 2 and comma y sub 1 we have 1 and our y sub 2 is negative 3 divided by 2. Now, let's simplify. Negative 3 minus 3. We apply the rule of integers. If we have the same sign, we are going to add and copy the sign. Negative 3 minus negative 3 is negative 6 over 2. Now, 1 minus 3, negative 2 over 2. Now, let's simplify further. Negative 6 over 2 equal to negative 3. Negative 2 over 2 is negative 1. Now we have our vertex. So our vertex will be negative 3, comma, negative 1. Now, since we have focus, directrix, and vertex, we can plot these givens. Now, after plotting our vertex, focus, and directrix, we can finally get our focal distance. Our focal distance, we are going to count from vertex to focus and vertex to directrix. Now, let's try to count. 1, 2. So, again, let's try it downwards. Vertex to directrix. 1, 2. So that means our focal distance must be 2 units. Now, let's get to our standard equation. Our standard equation will be, now, after getting our focal point, vertex, we can finally get our standard equation. We're going to use the formula x minus h squared equals 4py minus k. Now, Let's substitute. So we substitute h, -3 square equals 4, and our p, or our focal point of 2 units, and y minus parentheses because we have -1. Now we can simplify. X plus 3, negative times negative will be positive, equals 4 times 2, 8, times y plus 1. Now, this is our standard form. So, we can get our latus rectum. We can see in standard form, we have 8. So, our latus rectum will be 8. We divided it by 2, we'll get 4. After getting our latus rectum, we will count from focus 4 times from left to right. So, we have 1, 2, 3, 4. And another side, 1, 2, 3, and 4. Now, again, what if I don't have graphing paper or I can't graph? Let's manually compute it. Remember, our parabola opens upward. The x-axis will be moving. Let's go back to our focus. -3, comma, 1. So, RLR1, -3, plus our latus rectum, 4, comma, 1. So it will be 1, comma, 1. This is our LR1. And our LR2, -3 minus 4, comma, 1. So it will be -7, comma, 1. This is our LR2. Now I will plot this in Desmos. Now, after plotting the latus rectum, and we plotted all the parts of parabola, like focus, directrix, vertex, and we also found our focal distance and latus rectum, we can finally check if our standard equation is correct. So, I'm going to put our standard equation in Desmos. Now, focus at -3, 1, and directrix at y on -3, and we get the standard form of this. X plus 3 squared equals 8, y plus 1, put it on Desmos, and it matched correctly with the given vertex and latus rectum. So, our standard equation is correct. Now, after solving, let's get to the other part of our lesson, standard form to general form. In our screen, this is the parabola in x-axis. So, we have x minus h squared equals 4p y minus k. So, we simplify x minus h, we get x squared minus 2hx plus h squared. And then, in other side, we distribute 4p to y, getting 4py. And we distribute 4p minus k, getting 4pk. Now, we just rearrange it. We get x squared minus 2hx minus 4py plus h squared plus 4pk. So, our negative 2h will be our c, and our negative 4py will be our d, plus our h squared plus 4pk will be our e. So, it will be like this, where our C is negative 2h, and our D is negative 4p, and our E is h squared plus 4pk. So these are the formulas we can use. But in this lesson, we are going to use different method in getting the general to standard form. This is the y-axis, our general form to y-axis. Let's head to our last problem example. Now, for our last given, You have 2x squared minus 12x minus 9y minus 48 equals to 0. So the other method we will be using to get the standard form of the general form is the perfect square trinomial. So how are we going to use this? Let's group x terms. So we have 2x squared minus 12x equals. We are going to put negative 9y and negative 48 to other side. If we are going to put a term to other side, we will change the sign. So it will be positive 9y plus 48. But how are we going to use perfect square trinomial? We have coefficient of x squared. So we will going to factor 2 out. 2x squared minus 2 divided by 12 is 6x. Copy the other side. Now we have our binomial. We will make it a perfect square trinomial to get binomial. How are we going to do this? So 2x squared minus 6x, and we're going to put a blank in there, equals 9y plus 48. Now, we're starting completing the square. We're going to take the coefficient of the middle term divided by 2. Negative 6 divided by 2 is negative 3. And after doing that, we're going to square that or times it by itself. We get positive 9. We still have 2 outsides. So we're going to times 2 times 9. So it will be 18. Now, we finally have a perfect square trinomial. How can we make this a binomial? We're going to copy x and our value here did we get earlier by dividing the coefficient of the middle term into 2. We have negative 3. We copy negative 3. Now, we have common. We have 48 plus 18. 48 plus 18. So we have 9y. So we have 9y plus 48 plus 18 equals to 66. Let's ask ourselves, is this the standard equation? No, it's still not the standard equation. So what are we going to do next? We're going to factor 9. Why? So 9 divided by 66, we will get 22 divided by 3. So this is factoring out 9. So let's try to check it. 9 times y, 9y. 9 times 22 divided by 3 equals to 66. Now, is this a standard equation yet? We still have a value of 2 here, so we need to get rid of that. How? We're going to divide everything to 2. So, we're going to get x minus 3 squared equals 9 divided by 2 parenthesis y plus 22 over 3. Now this must be our standard equation. Now in standard equation, we can see our vertex. Our vertex is h and k. So vertex equals to, if we're going to put the vertex value of h, we are going to change the sign. So with it negative 3, it will be positive 3, comma, 22 over 3. This is our vertex. And in our standard equation, we can already see our latus rectum, 9 over 2. Let's solve for latus rectum. We have 9 over 2. We're going to divide it by 2. So it will be 9 over 4. This is our latus rectum. Now, let's try to find our focal point. How are we going to find our focal point? In our standard equation, the middle term is 4p. And we will going to equate 9 over 2 to 4p. Then we divide to 4, so we cancel 9 over 2 divided by 4. So we will divide, in dividing fraction, we will get the reciprocal of 4. So it will be 1 over 4, and we're going to times it. Equals 9, 2 times 4 equals to 8. So this our focal length, 9 over 8. Now, after getting our focal length, we can get our focus. But how are we going to find our focus? So in a standard equation, our parabola is open upwards. So our focus will have a y change. So we're going to start in our vertex, which is 3, negative 22 over 3, plus our focal length, which is 9 over 8. Let's simplify. 3, negative 22 over 3 plus 9 over 8. We will get negative 149 over 24. So this is our focus. So if we have focus, we can get our directrix next. Directrix, if in our focus we add, in our directrix we minus. So 3, comma, negative 22 over 3 minus 9 over 8. Now let's simplify. Negative 20. Now let's simplify. 3, comma, negative 22 minus negative 9 over 8 is negative 203 over 24. So this must be our directrix. We can find our latus rectum next. How are we going to find our latus rectum? So now let's get our LR1. Let's start to our focus. In LR1, we already know that our parabola opens upward by looking at our standard form. So we're going to start at focus. It will have a x-axis change. So LR1 equals 3 plus our value that we got, 9 over 4, plus 9 over 4, comma, our focus, which is negative 149 over 24. So let's simplify. 3 plus 9 over 4 equals to 21 over 4, comma, we copy 149, 24. So this must be our latus rectum. Now let's get our latus rectum to 3 minus 9 over 4 comma 149 over 24. 3 minus negative 9 over 4 will be 3 over 4, comma 149 over 24. So this will be our latus rectum 2. Now, we can finally graph our parabola. First, let's plot our points. So, after plotting it in Desmos, we got these following points. I forgot to mention, our directrix will be lying on y-axis. Our directrix will be y, copy the y, copy the y-axis, which is negative 203.24. So this will be our directrix. Now, we can finally graph our parabola. Let's put the standard equation in our Desmos. Now, as we can see, our parabola perfectly lined up to our vertex and latus rectum. Therefore, 2x squared minus 12x minus 9y minus 48 equals 0. General form to standard form will be x minus 3 squared equals 9 over 2 parenthesis y plus 22 over 3. And this is our standard equation.